solving trig equations. Some reminders up there, remembering that when we solve trig equations, what's unique there is they may have an infinite number of solutions, so that's going to require us to express our answers as a general solution. In this activity, we're going to review those key things to remember when we're solving those trig equations, and also explore some more complicated ones that utilize factoring or some of our trig identities. So remembering our three trig ratios from previous courses, and in this course we introduced cosecant, secant, and cotangent, if you hopefully remember that. So cosecant is 1 over sine, secant is 1 over cosine, and cotangent is 1 over tangent. So just the reciprocal functions, and we'll use that reciprocal idea as we fill out some other things. I filled this out already. You guys should hopefully know all of those. Remember, that's going to be helpful just if I have, for example, sine of 0, I'm going to be over here at 0 for the answer. Sine of 90, it's the y value up there, so we'd be at 1, and so on. So it gives us an idea of what type of number we're going to have, positives and negatives, and then if we do land on the axes, what number it should be between 0 and 1 and negative 1. We also have other exact values. They come off of our special right triangles, 45, 45, 90s, and 30, 60, 90s. So remembering these ratios, and we should hopefully be able to fill in that chart down there. The 0 degrees, that's just going to be right over here at that initial spot at the 3 o'clock position. So we should be able to fill those in pretty quickly, I would hope. So the sine at 0 would be 0. That's our, come on now. The x value is 1. It's the y over the x, so I'm just going to put that in that box so I remember. It's actually sine over cosine, so it's already drawn that way, so 0 over 1 is going to be 0. Cosecant is 1 over sine, so I just take my sine answer, and it's 1 over 0, and that's going to be undefined. I'm not going to be able to write that all in there. Secant is 1 over cosine, so 1 over 1 is going to be 1. And then cotangent is 1 over tangent, or the reciprocal of tangent if I write tangent as a fraction. So that one's going to be 1 over 0, which is also going to be undefined. All right, then we get to our 30. So I'm going to use this triangle right here. So here's my reference angle. So there's my 30. And I can just use my trig ratios that I have up here and hopefully fill these out pretty quickly. And maybe I remember them, maybe I draw my first quadrant, 1, 2, 3, 3, 2, 1. Some way to remember those. So sine at 30 is a half. Cosine at 30 is square root of 3 over 2. Tangent's going to be 1/2 over the square root of 3 over 2. So my square roots, or my 2's, are going to end up simplifying out. And I'm going to end up with 1 over the square root of 3, which we know we're not going to leave like that. We're going to multiply top and bottom by the square root of 3. So I get the square root of 3 over 3. Cosecant's 1 over sine, so the reciprocal of 1/2 would be 2 over 1, so we'll write that as a 2. Reciprocal of square root of 3 over 2 is going to be 2 over the square root of 3. Again, not leaving the square roots in the bottom. So we get 2 square root of 3 over 3. And then cotangent is the reciprocal of 1 over the square root of 3, so that just is the square root of 3 over 1. 45s, we'll go over to this triangle. Here's my 45. Again, just looking at the ratios. So my sine ratio is the square root of 2 over 2. Cosine is also square root of 2 over 2. Tangent is the same number over itself, so that's going to be 1. Cosecant is now the reciprocal of square root of 2 over 2, so that ends up being just plain old square root of 2. And that's for both. And then 1 over 1, when I get to cotangent, would also be 1. 60 degrees. So 60 degrees, go back to my triangle. Now this is my reference angle. So as I look at the sine, opposite over hypotenuse. So now I'm at square root of 3 over 2. We'll notice similar numbers that we had over in the 30 degree column. 1/2. This one is going to be the square root of 3 over 2 over 1 over 2. The 2's would cancel, so I just get the square root of 3. Cosecant is going to be 2 over the square root of 3, so that's going to simplify with a 2 square root of 3 over 3. And then the secant is 1 over my cosine, so that's 2 over 1, which would just be 2. And then cotangent is 1 over the square root of 3, which we just said before simplifies to the square root of 3 over 3. And then 90, so we're back up to our unit circle idea at 90. So the sign at 90, the y value, remember that's our y, that's our x. The y value at 90 is going to be a 1. The x value is going to be 0. 1 over 0 is undefined. And then 1 over 1 is going to be 1. 1 over the cosine when I get to secant is going to be undefined. And then for cotangent, this one's a little different. 1 over undefined. You might think, well, what is that going to be? Isn't that just undefined? We can also think of this as the x over the y. So when we think about the x over the y, it's 0 over 1, which in this case is actually going to be 0. All right, so that's our first part where we're just filling out the table. Here, that's going to describe when the trig functions are positive and negative, and also in that last column, fill in what the period is. Again, this is the idea of why we're going to need general solutions and why we're going to need multiple solutions in each period. Because, for example, sine is positive in 2 of the quadrants, but my calculator is only going to give me 1 of those answers. So we're going to go through them in the columns. In quadrant 1, everything is positive, so we're just going to grab positives for all those. X's and Y's, and then those ratios would also be positive. In quadrant 2, that's where the Y is going to be positive, but the X is going to be negative. When I divide a positive by a negative, I'm going to get a negative. And then remember, cosecant is 1 over sine, so positive 1 over a positive will be a positive, 1 over a negative would be a negative, and 1 over a negative would be a negative. When we get into quadrant 3, that's where we're going to be where the x's and the y's are both going to be negative. So down there in quadrant 3. But when I divide two negatives, I get a positive. 1 over a negative would be a negative. And then we still end up with a positive for cotangent. Quadrant 4, that's where our x's are going to be positive and y's are negative. So sine is going to be negative. Cosine will be positive. Tangent would have to be negative, negative divided by a positive. Cosecant is going to be 1 over sine, so 1 over a negative would be a negative. 1 over a positive would be a positive, and 1 over a negative would be a negative. Period for these then, 360 for sine and cosine. These are degrees, 180 for tangent. And then cosecant and secant are just going to be reciprocal functions, so those are also going to be 360s. And cotangent is going to be back to 180. So there's our table for number 2. Gives us an idea of when we're going to be able to find, where we're going to find answers that are going to correspond to what our calculator gives us, where we're going to find that second answer. All right, then you're given an example on solving. So when we're solving these trig equations, remember the first thing is we want to try to get that trig function by itself. So we want to get cosine 4x by itself first. So first step would be subtract 3. Again, the steps are given. I'm not going to read through the whole thing, but divide by 5, and then we inverse cosine. When we inverse cosine, our calculator gives us one answer. But we know from our knowledge, superior knowledge of the unit circle, that when I'm talking about a cosine value, of 0.8, well, that means I'm somewhere over here. But it's also the x value, the cosine value is also positive down here in the fourth quadrant. So that's why we see we get that answer from the calculator, but we're also going to write our second equation. And in this case, for cosine, we can just do the negative, because if I go in the negative direction, I'm going to have the same cosine, same x value. So right after I type this in, inverse cosine of 0.8, that's when I use my calculator, get me that answer. But I also want to find the other answer. And I also encourage you to make a general at that case as well, knowing that you can go around the circle more than one time and still land at that point on the unit circle to get my answer. Then to finish solving, we would just divide by 4 and divide by 4. When we divide everything by 4, and here would be the general solution. So these two equations are going to generate all of our answers for that original equation up there at the top, where I wanted that to equal 7. So we talk about there, one of the key parts is finding that second set of solutions. Most students can do this part just fine. Where they run into mistakes is this part over here, finding that second one. The calculator is only going to give you one answer when you do the inverse, sine or inverse cosine. We know that there are going to be two answers within each period, sometimes, oftentimes, and you'll need to be able to reason with the unit circle to find that second solution. So that's what we're going to work on for these solving examples today. All right, another example is when we have the reciprocal functions. So it is very, very similar to what we just did. We want to get that trig ratio by itself. So we're going to subtract 3 and then divide by 5. So now I have the trig ratio by itself. Now remembering that cosecant is 1 over sine, it's a reciprocal trig function. We can take the reciprocal of the right side, now that I have just the cosecant over here, and I can rewrite that now as sine as long as I take what it was equal to and use the reciprocal of that answer. So sine of 4x equals 5/8. And now that question becomes just like how we finished off the last one. We're going to inverse sine. We get our answer from the calculator. We write our general solution. And now for sine, I have 38.68. So somewhere over here, where else is the sign positive? So on that one, I have to go over into the second quadrant. So to find that angle, I'm going to do 180 minus the 38.68. So that's how we find that. So inverse sine, we do 180 minus the answer that our calculator gave us. And then we divide by 4, divide everything by 4, and we get our two equations that generate all of the answers, and that's our general solution for that. So the only difference when we deal with the reciprocal function is this little step here, 3a, 3b. Make sure that we do the reciprocal because there's no cosecant button on the calculator. So I have to get it into sine or cosine or tangent. So I do that, and then I just follow the same steps as before. All right, so let's look at some examples. 3a. So I have a cosine of 3x in there. I need to get that by itself. So I'm going to start by subtracting 2. Then I'm going to divide by 4. And I get to cosine 3x equals 3/4. At this moment, now I'm going to inverse cosine. And this is what the calculator gives me, 41.4. But I know I have to make it general. 41.4 plus 360n, that's going to equal 3x. And I also know I need to make sure that I write my second equation. So my second equation for cosine, I know that the cosine would be positive 3/4 over here, and it would also be positive 3/4 over here. Cosine is the x value. So I can just use a negative angle, negative 41.4, and then finish my solving. So divide everything by 3. So my solutions are that equation and that equation, and I need to have both of them. 3b, here I've got a reciprocal trig function, so I'm going to, again, divide by 2 to start. I get to secant x plus 40 equals 5. There's no inverse secant button, so I need to change that into a trig function that shows up on my calculator, and that would be cosine. So I use the reciprocal trig function, cosine x plus 40, and I take the reciprocal of the 5. And reciprocal of 5 is 1 over 5. Now I can inverse cosine. Again, cosine is the x value. So I get rid of these two things, and I get x plus 40. My calculator shows me 78.46. Again, I don't stop there. I realize I could go around the circle lots of times, so I'm going to make it general, add 360. And I also realize that there's a second number, not just positive 78.46, but also negative 78.46. Finish the solving, subtract 40. When I subtract, there's no n on this 40, so it doesn't deal with this part at all. It's just going to deal with the 78.46 and just going to deal with the negative 78.46. So my two answers, and I think I already did the subtracting, so I really don't need that plus 40 in there anymore. We're given x equals negative 118.46 plus 360 n, and x x equals 38.46 plus 360. 8 plus 3 tangent 2x equals 17. So my first thing here is I need to get rid of this 8. So I'm going to subtract 8 from both sides. And I end up with 3 tangent of 2x equals 9. We're then going to get rid of the 3. Again, trying to get this tangent by itself. So divide everything by 3. We get to tangent 2x equals 3. At this moment, now I have the trig function by itself. So I'm going to inverse tangent both sides. Punch that into the calculator. And I get 71.6. And I get 2x equals 71.6. Now this is tangent, so some things to remember with tangent is tangent, I only need one equation, and the period is going to be 180 degrees. So now I just set up 2x equals 71.6 plus 180n. Still need to solve for x, so I'm going to divide both sides by 2, and we end up with x equals 35.8 plus 90n. So the 180n gets divided by 2, so I end up with a plus 90n for this particular question. All right, 3D. I'll start back with this one. Here we have 5 minus 3 cosecant 2x minus 25 equals 10. I've seen people try to put these two things together. You cannot do that. This has a multiplication of 3 times cosecant, and this is just a plain old 5. So if you think of this as plus negative, that might be helpful. Realize you need to get rid of the 5 and then get rid of the negative 3. So the first thing is to subtract 5 from both sides. So now I have negative 3 cosecant 2x minus 25 equals 5. And now I'm going to get rid of the negative 3 by dividing. And I get cosecant 2x minus 25 equals negative 5 over 3. So just leave that as a fraction for now. Because there's no inverse cosecant button, I need to change this to the trig function that I do have a button for, and that would be 1 over sine. So if I take the reciprocal of the left side, I can also take the reciprocal of the right side and rewrite it as sine 2x minus 25 equals negative 3/5. Now I'm ready to inverse, so I'll inverse sine. And when I punch it in the calculator, I get negative 36.9. Remember, this is the time where then I make it general. And I also write my second equation. So for sine, I'm going to look at the 180 minus the angle that was given to me by the calculator. And that's where my second angle is going to be. So this is in the 4th quadrant. And where else would the sine be negative 3/5? Over here in the 3rd quadrant. So 180 minus is the way that I can find my angle, my second angle for sine. All right, then we're solving just like we did before. We're going to add 25, and then we're going to divide by 2. And there's one of my solutions, and I do the exact same steps over here, add 25 and divide by 2, and there is the other solution. So x plus negative 5.95 plus 180n, and x equals 120.95 plus 180n. There's number 3. All right, number 4. Number 4, we're going to look at polynomial trig functions. So not only are we going to be dealing with trig, but we're also going to be dealing with some factoring. So set your trig equation equal to 0. I think we've set that up mostly for you already. We're then going to factor it. So I have some comparisons just to regular polynomials as we go. That's what you want to think about. And then set each factor equal to 0. Solve each trig equation that we end up with. And we may end up with no solutions. We could end up with multiple solutions like we have on the ones back on number 3. And again, we'll express those as general solutions. So looking at the example, they say cosine squared theta plus cosine theta equals 0. It's already set equal to 0, so now my job is to factor this. So there's a GCF, greatest common factor of cosine in both of those. So I took out a cosine, and I'm left with cosine theta plus 1. All right, so then we're going to set this factor equal to 0 and this factor equal to 0. On all of these, on number 4 and 5, we're able to use exact values. So I don't have to really use my calculator actually for any of these. So I end up with cosine theta equals 0. So where is the x value equal to 0? That's at 90 degrees. It's also at 270. It's also at negative 90, and so on. So I can write that one as 90 plus 180n. So I can actually write that as just one equation. And then for the other part, the other factor, cosine theta plus 1 equals 0. So I solve that, subtract 1 from both sides, And where is the x value equal to -1? And that's at 180 degrees, but I could go around the circle multiple times. So we have two general solutions, one for each of the factors. And I got them all, so on part C, we're good. All right, 5a, so now we need to be able to factor. So this one, again, there's two terms. I've got a greatest common factor of sine theta. So I factor out the sine theta. I'm going to set each factor equal to 0 and then solve. So this one I can solve right away. Where is the y value equal to 0? That's going to be at 0, at 180, at 360, and so on. So there's my pattern for this particular side. And here I'm going to add 3 to both sides. I get sine theta equals 3, and that never happens. So I don't have a solution for that side. So that's it for 5a. 5b, sine squared theta minus 4 sine theta plus 3. So that one is set up like a trinomial. I've got 3 terms. Sometimes it's useful to think of it like this. Instead of a sine theta squared, think of it as just x squared. So if it looked like this, how could you factor it? And we could factor that into x minus 1, x minus 3. And we'll do the same thing, but instead of the x, we're going to use sine theta. So then we'll set each factor equal to 0 and then solve. So we're going to add 1 to both sides for this one. We'll add 3 to both sides for this one. When is the sine equal to 1? So when is the y value equal to 1? That's going to be at 90 degrees. That's the only place it happens. So then plus 360n. And we just learned in the last one, sine theta equals 3. That never happens. So the biggest that we get for sine theta is going to be 1. And the smallest is -1. So that solution doesn't have, that part doesn't have a solution. So that's it for 5b. 5c, now we've got tangent. Tangent squared theta plus tangent theta minus 2 equals 0. So again, if you think of it like x's, how would that factor? And I could do x plus 2, x minus 1. And that's what we did with the tangents. So tangent theta plus 2, tangent theta minus 1. And now we'll set each factor equal to 0. Subtract 2 over here, add 1 to both sides over here. And at this moment, I will inverse tangent. I guess I did need a calculator for this one. So I inverse tangent 2, and I get negative 63.4. And I inverse tangent 1, and I get 45. Period on tangents 180 degrees, so make sure we add 180 on those. And those are the two solutions that we would have, two equations we would have for the general solution. Part D, 2 sine squared theta minus 3 sine theta minus 2. Think of it like x's. So that one has a leading coefficient that's not 1, so we have to be a little bit more careful. 2x plus 1, x minus 2, looks like it'll work. I'll get 2x squared. Negative 4x and positive 1x would give me that negative 3, and 1 times negative 2 would give me the negative 2. So in place of the x, I'm just going to put the sign, and there's my factoring over here. Set each factor equal to 0. 2 sine theta plus 1 equals 0. Sine theta minus 2 equals 0. Subtract 1, divide by 2. Did that in one step. I'm sure you can handle that part. And this part over here, lucky me, sine theta equals 2, that will not have any solutions. So now I'm just looking at this. When is the y value equal to negative 1/2? So that's an exact value. Negative 1/2 is at negative 30. So that's in the 4th quadrant. And the sign is also going to be negative in the 3rd quadrant. So my other solution is going to be over there. And that's going to be theta equals negative 150 plus 360n. You could use 210 degrees here, that would also work. You could use 330 degrees here, that would also work. So again, some different options that you would have for those. 5e, again, we've got a leading coefficient. I think this one's going to factor the same. We just have a cosine instead of a sine. So we'll set that up again. Subtract 1, divide by 2. That part's not going to have a solution again. Now, where's the x value negative 1/2? That's going to be over in the 2nd quadrant and in the 3rd quadrant. So exact value at 120 degrees and then at negative 120 degrees. So again, the factoring part you have to be able to do, and then it just becomes like our solving was back on number 3. And the last one, 4x squared minus 4x plus 1. This is actually 2x minus 1 times 2x minus 1, so 2x minus 1 squared. So really, I'm just going to have that one factor I'm going to set equal to 0. That's the only factor that I have. It just is used twice. So we'll add 1, divide by 2. Where is the y value equal to a half? It's going to be at 30 degrees, first quadrant, and it's going to be positive 1/2 also over in the second quadrant. We're talking about the y value, so at 150 degrees. So we would have those two equations. All right, so those are the polynomial trig functions, being able to do some factoring and then some solving from there.